So are you guys able to see my PDF?
Yes, sir.
Okay. So in today's lecture, we are going to take up this experiment number 7, that is electrochemical machining. And in the last class, I told that our mechanical engineering is being subdivided to 3 parts, namely thermal, manufacturing, and design. We have covered 1 to 5 experiments of thermal domain. Manufacturing, I told 6 and 7, but 6, 7, and 8 are also, all 3 comes under manufacturing. And design, we have one experiment, 9th experiment, and that is robotic system, simple robo, to understand robotic, simple robotic system. 6th, we had lathe machine, which falls under conventional machining process. Today we will talk about electrochemical machining, which comes under non-conventional machining. In conventional machining, we kind of use brute forces in order to change the shape of the raw material. Maybe we may cast it, we may forge it, we may bend it by brute forces, rather like impact or kind of pressurize it. But in non-conventional machining, we use chemical energy or chemical means, chemical potential or chemical or thermal or some sort of, through some sort of chemical reactions. We use chemical reactions to machine my parts. Okay. And the specific chemical reactions that this particular electrochemical machine uses is electrolysis. Okay. So let us first go through, in order to understand the operating principle of electrochemical machining, we first have to understand what electrolysis is all about. So in yesterday, I also had a power cut, so I couldn't prepare my PPT. So we will be looking things from the PDF itself. Electrolysis is a chemical process which occurs when electricity current is passed between two conductors dipped into a liquid solution. Okay, and what is the aim? So the aim is, let's suppose I have a container in which liquid is contained, which is your electrolyte. In this case, we have CuSO4, copper sulfate aqueous solution, and we have two electrodes over here. One is called anode, one is called cathode, based on the polarity of your voltage that is being given to it. So with the voltage source connected in this way, electron is going to flow this way. Okay, and this is your copper metal, maybe new copper metal. This is your copper plate that is old, and you want to plate it, or you want to make it make a new copper surface on top of it. So as an example, you sometimes you may have some designer ornaments that is not of gold, you can say it's a fake ornament, and you can actually plate it through gold. So this is also called gold plating. Okay, and in this also you use some sort of chemical, electrochemical machining. So you have a new gold over here. The the shopkeeper have new gold over here. He put it in electrolyte, and your ornament will be here, and your gold will be decomposed from here and will be deposited on top of it. This is how the electrolyte process happens. And what is the reason for of doing that, I mean, of happening that? What happens when we apply the polarity here? I mean, we connect your plate, one plate to another plate. uh, the electron starts, excess electron, free electron starts moving this way, and it is going to be accumulated on top of it, on top of the surface, your free electrons, electron minus. Okay, once electron minus is here, and once the free electron starts moving, so this copper is going to be converted chemically as copper plus 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 2 electrons will be liberated. So copper, positive copper ions is being generated here, and this positive copper ions is going to migrate to this particular site slowly and steadily, and it will be accumulated, it will be reacted with this electron, these electrons, and make a, so Cu2 2 plus 2 electrons over this side will give you copper metal kind of, it is being plated on top of it. Okay, so this is a electrolytic process. This is called, this whole system is called electrolytic cell, and the medium over here is copper sulfate aqueous solution. This copper sulfate aqueous solution has no purpose other than it 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 is there just to migrate your copper ions from one side to another side. That's it. So these are the three reactions that are happening. Okay, this reaction is happening at cathode, this reaction is happening at anode. Okay, and this particular experiment was done at the start of 17th century, so it's long back, it's 200 years from now. I mean, it's so. And Michael Faraday once, I mean, he first saw this kind of phenomena, and from then things got started. I mean, kind of we kind of using this process, electrolytic process, very widely in our machining process. So once we understand this machining process, this electrolysis, now we can move into actual machining process. But before that, we have something called Faraday's law. So you can also ask me, sir, what is the mass that is being deposited here? What is the quantitative measure of this mass? So yes, so Faraday did this experiment already long back, and he found that your mass is directly proportional to the area of your plate. The current that is being provided, it is directly proportional to the time also, and it is indirectly proportional to the valency of your metal. And I mean, you may ask why it is inversely proportional. I mean, I don't have an answer, because I'm not the expertise on the chemical reactions. Okay, my domain is fluid mechanics and mechanical engineering. So actually this particular experiment is more focused towards chemical engineering. Okay, you may ask some of the chemical faculties or your chemical engineering colleagues, they may answer better. But at this moment of time, we will take this as a granted that yes, this happens. I mean, this cathode and anode, and your metal ion is going to be got a part and is going to be deposited on this site, this particular site, and we take this thing as a granted, and we just taking this granted, and we can use this particular thing in our machining process. I mean, if you ask why it is happening, then even I don't have a particular answer, because I mean, it involves some sort of chemical, all sorts of chemistry and chemical processes that happening inside. But we just take the things as a granted. This mass can be directly proportional. This seems also logical. Also, more the area, more the electricity is being passed, and more time it is being passed, the more the mass will be accumulated. It is inversely proportional to the valency of the metal, and the F is some sort of Faraday's constant, and is the amount of electric charge necessary to liberate it. Maybe some threshold or something. You may also check in some books, but this is not necessary right now. You just have to understand this. A few other characteristics are such as when things are being done in electrical manner. So you have a voltage source, you have some electricity that is moving around. This is a plus minus. So velocity is proportional to the resistance. Oh, sorry, velocity. Sorry, no, I'm really sorry. Voltage is proportional to the current, and the R is the constant material constant. The is called resistance of the material. All sorts of things. So it's not actually necessary here. This resistance can also be thought as a resistivity area and conductance, probably conductance. Fine. So I'm skipping these things. Okay, this is not that necessary, but yes. Now we start with the working principle of electrochemical machining. In order to understand it better, let us try to first watch this video first.
Electrochemical machining, or ECM, is a way of machining a part without actually having any contact between the tool and the workpiece. The workpiece is charged positively, as you can see, and the tool is charged negatively. And between the two pieces, there is a tiny gap where they don't actually touch, but there is a electrolyte fluid between the two that slowly removes atoms. And as the tool is slowly moved down towards the workpiece, more and more atoms are removed until the workpiece conforms to the same shape as the tool. This is convenient because there is no actual contact, so there's no tool wear and no friction, which causes heat. This can be used for a variety of parts in many complicated shapes, such as this cylinder that has been machined with a sphere. And this can also be used for tiny parts.
Okay, this was a short video, but this could give an idea of, without even giving a brute force. We are able to machine things. Okay. So what happens here is, you have seen, you will have, this is your tool, that this kind of desired shape you want uh, on this particular site, and this uh, down anode thing is your workpiece, and this is your tool. So tool is made up of cathode and anode. How? Just by passing or connecting it through some voltage source. And once we do that, uh, we also have to keep moving our electrolyte. such as CuSO4 solution, aqueous solution, in this gap and flow through around continuously. And once the electrolyte is given, the ions, copper ions, are going to be digged out. Copper ion, Cu, if at all, if things are made up of Cu2 plus is being decomposed into solution, and it is going to removed from the surface. Okay, and parallelly this tool is going to be fitted forward in this way in order to give a proper shape. So this is at thing at t is equal to 0, at t is equal to some other time, some time t dash. You will see that you actually acquired the proper shape what you desired at t is equal to some other time. Isn't it beautiful? Without even giving a brute force. We are not going to cut anything. We are not going to give a force on it or wear or tear, nothing, no stresses. Through chemical action, you are going to achieve your desired final product. Isn't it? In our lab, we have electrochemical machining, and which would look something like this. So this particular guy is your tool, and this particular guy over here is your workpiece. Okay, and you need to flow your electrolyte in between. So we have electrolyte reservoir which is going to be filtered, and through pumps it can be taken up and it can be poured into in between the gap of this tool and the workpiece in order to provide the electrolyte nature, or in order to make it as a electrolyte. And this can again be collected, and this thing could be keep on going steadily. There is a power supply which gives positive and negative polarity to the tools and workpiece respectively. Nothing more to talk about here. We have a link to show also. So there is a virtual lab. They made it. So that video was more comprehensive, it seems. So we'll take copper, let's suppose, or aluminum. Maybe 3. We start with power supply. See, your electrolyte reservoir pumps your electrolyte into the gap between tool and workpiece, and excess electrolytes are again collected in the reservoir, and this keeps on going. And in the meantime, your tool is going to be moved downwards in order to machine this brown workpiece. So yeah, it's a beautiful way to remove to machine things. So yes, we will not talk much today. In the next class, we will take up experiment number 8. That actually is kind of, so far we have talked about something, everything, all the time we were talking about the removal of something, removal of materials. But in the next experiment, we are going to talk about additive manufacturing, and this process are often accompanied through 3D printers. You might have seen it somewhere. We have the 3D printers at our lab also. I will talk about it. So any final product you want, you can get it through 3D printers as well from nowhere. Okay. And the last experiment, since we have, let's talk about the timelines. So 19th we have finished our 7th experiment, 26 we will be finishing our 8th experiment, and second we will be finishing, 2nd June we will be finishing our 9th experiment, that is the robotic system, and that will end our uh, elements of mechanical engineering lab, and from 4th you might be having exams. So is it fine to end it at 4th, end it at 2nd, right? So yes, I will not go much beyond, and even I don't want to take attendance today, because I believe that uh, most of the homes are still under power outage. So keeping that in mind, I will not take attendance today. That's it from my side. If you have any questions, uh, obviously I'm not a chemical engineer, and this particular experiment is, if you want to know the reasoning, exact reasoning of what happens, the ions are going to break up from the side. So those things can be uh, answered by proper chemical engineers. I will not give the correct answer, but yes, again, since this is in curriculum, we have to take this as granted, and just we will take the advantage of this electrolytic process in our machining, unconventional machining process. Okay, so anything else you want to add or suggestion? No, yes. And I want you guys to write these 6 questions as a assignment for this lab. Try to write it in your own words. These are simple. These are simple questions. So you may answer. Yes. Anything else, or yes, no? At least somebody tell, or we will leave this class. No.
No, sir.
I should not leave, or no questions.
No questions, sir.
Okay. Fine. And if you don't have any questions, then we may leave. Thank you. So I'm leaving a bit early because this experiment was a bit. Um, I feel that you guys might have understood through the video also. And once you come to our campus, you will have a better feel of how these machines work actually. These late machines, these electrochemical machines, and all. We have these machines at our lab. Okay, fine. Then let's leave this class. Bye.
Thank you, sir.
Thank you.
Thank you, sir.